going on, guys? Let's do this problem right here. So the question is asking a water trough of semicircular cross section of radius 0.6 meter consists of two symmetric parts hinged to each other at the bottom. The two parts are held together by a cable placed every 3 meters along the length of the trough. Calculate the tension in each cable when the trough is filled with a rim of water. So let's see how we can calculate this one. So first of all, we separate this diagram into half, right? And what I'm going to do, I'm going to draw this part separately. So this is going to be the part 1/4 of the circle. And let's put all the forces acting on it. So we are going to, since this is pulled by a cable, we are going to have a tension in this direction, and then also we are going to have hydrostatic resultant force. That's gonna be this shape, and we choose different colors. So for this is a triangle shape, so the centroid of this triangle is going to be 1/3 of it. So this is going to be acting exactly right here, FR. And if I say this is A, we are going to have, since this is a hinge, we are going to have two forces unknown, AY, AX, and then we are going to have the weight acting on this. So for the weight, so we know, first of all we have to know what is the centroid of this 1/4 of the circle. So for one, if a semicircle, the centroid is going to be somewhere here, that is 4r over 3/5. So this is a equation for semicircle. So what's going to be 1/4 of the circle? It's going to be the same thing. It's going to be 4r over 3/5 for this one too. So that is going to be, so we can say this is 4r over 3/5, and that's where the weight is going to act. So this is going to be the W pulling down side, and these are the all forces we have. And also we are going to have small reaction right here. So let's say this is R, and we have to calculate this T. T is the question. So let's see how we can find the T. Since we have too many unknown forces in this location, A location, so what we can do, we can simply eliminate by taking the moment around it. So let's take the moment. So if I take sigma MA equal to 0, this is going to give us, so I take the clockwise positive, FR time, so this radius is provided 0.6 meter, total is 0.6. So FR is going to be, since this is a triangle force, this is going to be 1/3 of this one, so this is going to be 0.2 right here, 0.2 right here. So that is the distance of this one, FR. So that is clockwise, so this is going to be 0.2 times FR, 0.2 FR, plus we are going to have weight also acting in the clockwise, plus W times 4R by, that's the distance, centroid distance, 4R by 3/5. Then so that is the distance. And what else we have? We have the tension right here. This is counterclockwise, so I bring, this is going to be minus, but I bring other side of the equation. This is going to be equal to T times the total distance is 0.6. So this is going to be the equation. Now if we look at this, we have, this is radius, R is known, 0.6, and we have to find the weight and the FR, right? This force and this weight of this water molecule, water. So let's see how we can calculate this one. So we can calculate the force FR by taking the pressure at centroid times the area. I derive this equation from P is equal to F over A and F is equal to P times A, right? So we have this equation right here, so we can also P is equal to rho g h, but in this case this is PC centroid, so this is going to be at centroid, height of the centroid, and we can replace this one by rho g hc times area is going to be radius of this one and the depth is provided 3 meter, so radius times the depth. Rho g, rho of the water is density of the water is 1000 kilogram per meter cube, 1000 times acceleration due to gravity is going to be 9.81 hc. So for this one it's going to be a total different thing. So pressure, the pressure is going to be acting like for in this surface, like let's think it out like this. So for this one the centroid is going to be half of this. So we know this total distance is 0.6, so half of this is going to be 0.3. So that's the distance we are going to put right here. So this is 0.3 times the radius 0.6 times the depth, that is 3 meter. And now if I calculate, multiply everything, that gives us the FR. That's equal to 5.297 kilonewton. And now we have the FR. Now FR, we have to find the weight to calculate the T. So W is going to be equal to mg. We can write m is equal to rho v, right? Density times the volume. So in this case mg is going to be rho vg or rho gv, same thing. Rho g, we know rho of the water is 1000, g acceleration due to gravity 9.81, volume that we had to find out. So let's see, 1000 times 9.81 times the volume. So volume of the 1/4 of the circle, so it's going to be 1/4 times 5r square times the depth. So depth is 3 meter times 1/4 5r square. So let's calculate, 1000 times 9.81 times 1/4 5, radius is 0.6 square times 3, and if I calculate this value, this one gives us 8.3211 kilonewton. Now we have W and the FR. We can simply substitute these values. So this is 0.2, and if I calculate this one, 4r by 3, so 4 times 0.6 over 3/5 gives us 0.25465, and if I substitute this value in this equation and we have to bring this divide by 0.6, and that gives us the tension. Tension is equal to 5 point, if you calculate that, it gives you 5.30 kilonewton, and that's the question, and we have found the final answer. I hope you guys liked this video. See you next time.